Ethanol is being separated from water in a distillation column. The solution is being fed to the column at 60 liters per minute, 20% by volume of ethanol. You want the distillate stream to be at 10 liters per minute and 95% by volume of ethanol. Find the flow rate and composition of the bottoms. Also find what volume percent of the ethanol from the feed left through the bottoms. Okay, this problem here is a basic material balance. Here we have distillation column. We're trying to separate ethanol and water. First thing you want to do with material balance is draw a big black box around your system to define your boundaries. So here we have a feed stream and two product streams called distillate and bottoms. Next step is to figure out your missing components, which in this case is the bottoms flow rate and its composition. So in order to figure that out, we're start with overall material balance. In my case, it'll be feed, the input, is equal to the distillate plus the bottoms, which is your outputs. So we set this up here using our known flow rates. Using now, we can figure out our bottoms flow rate is 50 liters per minute. Next step is to move on to your component balances. Here we'll start with ethanol first, but you can pick whatever one you want. So using now, we just take our volume percent of ethanol times our flow rate for each of the inputs and set equal to the outputs. So again, we have feed is equal to distillate plus bottoms. Each one of those is times its respective volume percent of ethanol. So using that, we'll figure out that the volume percent of ethanol, in this case, will be 5%. So using now, we know that water should be 95% the bottoms product too. Now we can do a water balance here to just double check our work, make sure it's correct based off the ethanol balance. So over here we have a water balance, which is set the same way as the overall and the ethanol. So again, we have input equals output, and using some algebra, we'll figure out that X is going to be equal to 95% water, which matches what we had before. So we can assume our calculations are correct. The last step of this problem statement was to figure out the percent of your overall feed of ethanol that comes out in your bottoms product, which basically told you how well your separation worked. So here we have ethanol on the bottom, which is basically our volume percent times our flow rate, multiplied by the volume percent ethanol in the feed times the flow rate there. Using that to come up with 20.8% of the ethanol fed exits in the bottom stream.